teacher!
Hey guys, this lesson is about finding x and y intercepts when an equation is in standard form. Please note that if you are behind, the priority is 5.1, 5.2, and both 5.3a and b. So please skip this 5.4 lesson if you are completely behind, because the other ones are more important. If you're not behind, however, and you've been keeping up with the work, then you can continue on with this lesson. But again, if you're behind, please don't worry about this lesson. Prioritize the other ones first. So if you can recall, there was another name for initial value back in November when we were doing linear relations. Do you remember what that word was for initial value? It was kind of like the setup fee for phone plans or like the fixed cost for banquets. So the other name was actually the Y-intercept, because when you were going to graph things, if I was doing a fixed cost for a banquet, for example, if I had 0 guests, I would start at $1,000 or whatever it was. So initial value and Y-intercept are the same thing. And what are the coordinates of any initial value or Y-intercept? So from the graphing of 5.3b and 5.2 graphing, you should realize that any y-intercept along the y-axis has an x value of 0. So your coordinate is 0, comma, whatever the y value is. Every single x value at a y-intercept is 0. And similarly, what are the coordinates of any x-intercept? If I had a Cartesian plane, any dot along the x-axis has a y value of 0, and whatever the x value is, that's what you fill in. So for example, let's say this number was, 3, then the x-intercept would be 3, 0. If it was way over here, it would be like -7, 0, and so on and so forth. So 0 for x-intercepts is always the y value, and 0 for y-intercepts or initial value are always the x. And this comes in handy when you're trying to graph. So we've done rearranging in the previous lessons, which is really useful for graphing. And then today we're also going to figure out how to graph without rearranging things. And that's by finding the x-intercepts and the y-intercepts. And sometimes in word problems, it also is more meaningful to do it this way than to find the slope and just the y-intercept. So here we have an equation 2x minus y equals 4. And if I want to find the x-intercept, remember that every single value for x-intercept has a y value equal to 0. So that means that if I recopied the question, but I substituted 0 in for y, that means that y actually disappears, and I'm left with 2x is equal to 4, because 2x minus nothing is still 2x. And then this goes back to solving equations where you have to isolate for the x, and you do that by getting rid of its friend. In this case is the 2. So how do I get rid of this 2? It's 2 times x. So the opposite of timesing is dividing both sides by 2. And then x will equal, sorry, it's all crooked, but x is equal to 2. So my x-intercept is 2. So if I were to graph it, I can immediately plot it on my graph, and I need the x-axis, which is flat and horizontal, and I can just put a dot by x equals 2. And then similarly for the y-intercept, all y-intercepts have an x value of 0. So I'm going to substitute 0 for x by recopying the question. 2 times x, which is 0, minus y equals 4. And again, 2 times 0 or anything times 0 is nothing, so that disappears. And I would be left with negative y equals 4. And that negative sign is invisibly -1. So to get rid of -1, I can divide both sides by negative 1, not -4. I don't know why I keep drawing 4s. Oh my gosh, sorry, that's a -1. So -1 divided by -1 cancel out, and I'm left with positive y. And then 4 divided by -1 is equal to -4. So this becomes my y-intercept. So I can plot it immediately on the y-axis. I go down to -4. So I've got 2 dots on my graph, which means that I can connect the dots, and there is my line. And I should probably include arrowheads on both sides. So that's how we can graph something without figuring out slope and y-intercept. So there's another example we're going to do. It's 3/2x plus 2y equals 9. We're going to do the same thing. I got to figure out my x-intercept, and all x-intercepts have a y value of 0. So that 2y is going to disappear. So I can actually skip the first step from example 1 and just write 3/2x equals 9. Now, this isn't technically proper standard form because there's a fraction and you've never seen it before, but we're still going to do the same thing. 3/2x is the same as multiplying. So technically I can divide if you want to do that. But a lot of people are not comfortable with dividing fractions because they don't know what to do with it. I often write it this way, and then you actually know that you have to multiply by the reciprocal. So it's technically x equals 9 times 2/3. But if you don't like to do that, then you can just rewrite this part as, I'll write it on the side here. It could be 3x/2, and then you multiply both sides by 2 first, and then you divide by 3. So you're doing it in 2 steps, but I'm just going to do it in 1 step anyways, because it's not common to see a fraction in standard form. So if I remember my fraction dance, I do the straight across for multiplication. Do the straight across for multiplication. So 9 times 2 is 18. 1 times 3, because all whole numbers have a denominator of 1. So it's 18/3. And that reduces to x equals 6. So my x-intercept is going to be at 6 here. And then I got to do the same thing for my y-intercept. And all y-intercepts have an x value of 0, which means this first term is going to disappear. So I'm not even going to write. I'm going to skip that step. So I have 2y equals 9. And then I got to divide both sides by 2 to get rid of it, because it's 2 times y. 2 divided by 2 cancel out. Y equals 9/2. I didn't give you a nice question. 9/2 is the same as 4.5 technically. So it's not too bad to graph, because I'm just going to put it in the middle of 4 and 5 here. I can't remember if we give you fraction questions, but if not, just use a decimal. That's fine. So I've got my 2 points. That means I can draw my line like so, include my arrowheads, and then I am good to go for this example. Okay, example 3 is a word problem. At Kim Thornton's, a small coffee costs $1.60 and a Kimbit costs 20 cents. You spent $24 before tax. Write an equation to model a situation where x is the number of coffees and y is the number of Kimbits purchased. So hopefully this is a fairly simple one. You can pause here to see if you can figure out the answer. But I already got the let statement written out for you. So if it's $1.60 per coffee, per means times, the coffee in this case is x. So $1.60x plus 20 cents, and we're going to use not 20 but 0.20 so that it's the same currency. So you could have done 160x plus 20y, but I'm going to do it in dollars because it's equal to $24 total. So hopefully you got the equation easily, and most of you can logic your way through that. B is the new stuff today. Determine the intercepts and explain their meaning. So intercepts, I need to figure out the x-intercept first. In this case, it's coffee. And remember, that means that I make my y value equal to 0, which in this case is Kimbits. So in my equation, this y is going to go away, and I will just have $1.60 x is equal to 24. And to get rid of the $1.60, the opposite of multiply is divide. So divide both sides by $1.06. D, divide 24 by $1.60, and x is equal to 15 coffees. So that's my x-intercept. And my y-intercept, which is Kimbits. Sorry, my writing's super messy, but you get the idea. That means my x value has to be 0. So this one goes away because anything times 0 is nothing. So I can just rewrite it as 0.2. You can write the 0 if you want. You don't have to. 0.20y is equal to 24. And you're doing the same idea. It's multiplying by y, so the opposite is dividing. So divide by 0.2 on both sides. And y would be equal to 120 Kimbits. So I sort of jumped the gun on this one where it says explain the meaning. What it means is if I spent $24, the intercepts means I bought all coffees and no Kimbits. No Kimbits. And the y-intercept represents how many Kimbits I could buy if I didn't buy any coffees, because coffees was 0 in this case. So that's the meaning of the intercepts for this Kim Thornton's example. There's lots of practice questions in the Desmos, but if you're confused, you can follow these instructions. Take care. Have a great week.